Good morning, dear students, dear colleagues. Today it is a great pleasure to have with us Professor Adrian Florea from the University of Petrosani. Professor Florea will give a lecture in the field of mine planning design using computer program software. It is a subject that is very interesting to our department. We have already cooperation with the University of Petrosani. We have cooperated for several years with Professor Maria Lazar. So we start now our operation with Professor Florea, and we hope that this will be the starting point to strengthen our operation and to have also the opportunities to support some students from your university, or maybe some students of you can visit the University of Petrosani if you want to spend here some time within the Erasmus program or with the EURECA-PRO program also. So at the moment, I would like to welcome Professor Florea. Welcome. Wish you to have a nice day here, and we are ready to listen to your very interesting presentation. The stage is yours.
Thank you for the introduction. I must express my gratitude to Professor Galetakis and Professor Magoutakis who made possible this meeting. So
let's share the slides. Yeah.
Start sharing the screen. So as Professor Galetakis mentioned, the lecture is about using GEOVIA Surpac for different type of application in mining and environmental field. I am from the University of Petrosani, and I structured the lecture for today in 3 parts. The first part is a short presentation of the university. The second part is dedicated to flow stability analysis and involvement of Surpac because Surpac is not a software dedicated for flow stability. And the third part is dedicated to air quality modeling and involvement of Surpac, GEOVIA Surpac in this activity. So now we are here in Technical University, and I am from 1,500 kilometers away from Petrosani. Which is a town in the southwest center part of Romania.
We hope you didn't drive all this distance.
No, only the Google map. My car, airplane. Because it's really a long trip, and now in Petrosani it's about 20 centimeters of snow.
Okay.
So the university is located in the eastern part of the town, in the hilly area. This is the main entrance, the rectorate building of the university. And here you can see the location of the university over here. It's a little bit up. And town of Petrosani, it's at around 600-meter elevation. The university is up, and the mountains behind are over 2,000-meter elevation. You could see here the slopes who are came to skiing. This winter, it seems that we will have a lot of snow. So, our university functioned in Petrosani since 1948. The name of the university was changed in different periods of time. From 1957 was named Mining Institute of Petrosani. From 91 to 95 was named Technical University of Petrosani, and since 95 we are University of Petrosani because we have, in fact, 3 faculties which deliver various bachelor specializations. For instance, mining engineering faculty, which is similar with School of Resources, have specialization in mining engineering, mining survey, mining construction, environmental engineering and protection in industry, economical engineering, quality engineering, and safety engineering and industry. The second one is the Faculty of Mechanical and Electrical Engineering with specialization in electromechanics, instrumentation and data acquisition, computer engineering, industrial energetics, mining machines and equipment, industrial processing equipment, automation and applied informatics, transport engineering and traffic and machine building technology. And the third one is the Faculty of Science with specialization in finance and banks, accounting and management, information system management, economy of commerce, tourism and services, public administration, social assistance, sociology, mathematics and informatics. Also, you could see in this picture some aspects from different lab works with students at different specialization. And beside the bachelor programs, the university delivers also master programs. Faculty of Mining Engineering has master in computer-based mining survey and cadastre, occupational health and safety management, mining construction design engineering, project engineering and management, anthropogenic environmental impact assessment and ecological restoration, and environmental factors control and monitoring. The sister faculty, mechanical and electrical engineering, have master degree in electrical and mechanical system, industrial electrical equipment operation, processing, installation and equipments, information systems and technologies, applied information techniques and technologies. And the science faculty have master degree in strategic business management, human resource management, financial and banking management, accounting and auditing, social policies and social protection. Besides the master programs, the university ensure also doctoral studies in the mine, oil and gas, industrial engineering, electrical engineering, and systems engineering. Also, the university deliver postgraduate courses for continuing vocational training and development and for professional reorientation. Basically, those courses offer opportunities for adults. So here is a schematic map of campus. Over here is the main entrance, which I already showed you. The building group A, the building group B, the library and the information center. Here is the sport base. Over here is restaurant, and here is the accommodation for students. And you can see in the following slide image from the accommodation facilities from the students. The cost is quite cheap. It's under 100 euros per month for students. So we welcome you.
It's even cheaper here. It's zero.
Also, you could have some good time of sport. The university have a rugby team, which is in the National League. You see them in the training. And some surroundings. This is a hotel at 10 kilometers from the university in the mountains. Now the snow is not so big, but it will be. So you can come to ski. Here is a picture from downtown, and you see the university. It's a little bit up on the hill. Crete Mountains, where is a big national park. And in Hunedoara, at about 8 kilometers away, it's a medieval castle, Corvin Castle. So it is a little bit connected with Dracula story. Dracula story is known by everybody. So let's go to the second part of the lecture today. In fact, it's a case study on Rushkica marble quarry. It's so-called old marble quarry because this quarry is in operation from 1883. This picture was taken about 20-25 years ago. Now you will see that this area it's not visible because it is built an inner dump. Rushkica is not far away from Petrosani. Petrosani is here, Rushkica is here, in the same part of the country. The distance from the university to the marble quarry, it's about 120 kilometers. What was the problem, the question? The question was to analyze the slope stability of old quarry. Here is the foot of the quarry at elevation 630. The top of the slope is at elevation 748. Here is the inner slope. The inner slope goes from 630 to 671. And the extension at the moment when we made this study was about 80 meters. The geology in the area, it's a little bit tricky. Here was marble. And there is a slice of marble. Behind this, there is another slice of mixed material, schist, marble, clay, different other materials, and behind it's green schist. So we must create the geological model, and we must determine the geomechanical properties of all these type of rocks in order to proceed to the stability study. For stability study, we used slide 3 from rock science. I don't know if you work with rock science have a large package of dedicated software. So using slide 3 involves several steps. One of step is building the geometry. There is some tools inside slide 3 for building the geometry, but these tools are not quite comprehensive to cover all the aspects. And if the geometry is very complicated, there is another way. The geometry could be created with other modeling software and then will be imported in slide 3. So in fact, we did this using version 6.9 of GEOVIA Surpac. For building the geological model, we used a lot of various sources of information. And for completing this information, we carried out 2 exploratory drills. One is a horizontal one from the elevation 734, and the second one is one is a vertical one. And the second one is a horizontal one at elevation 688. You could see here the core recovered from this exploratory drills. From this course was made a sample for mechanical testing in the laboratory. Also, for modeling the morphology of the area, we used a drone, and the information, the points relevated with drone was then imported in Surpac. So this is the model generated based on the points from drone, and here you can see where was carried out the vertical drill hole, and over here you can see the horizontal drill hole. And right is helicopter view of the same area. So, based on the information acquired during the process of documentation, we was able to create the model of plans. This one is the separation plan between schist and mixed material, and this one is the separation plan between mixed material and marble. And you see where the exploratory drills was carried out. In order to import the model in slide 3, we create a virtual box and all the elements was cut to the level of this krypton box. So, I mentioned that part of the slope is not visible now because it's covered with inner dam. In order to create a model of this part, we used all the situation plans with elevations and limits of the steps. And finally, we was able to create the geometry of the area, and practically our geological model had four solids. One solid represents the marble. The second one represents the inner dam, which covers now the partially the slope. The third one is schist model behind the marble, and the fourth one is the mixed zone. We estimate that the mixed zone is about 30 meters wide. In mixed zone, we identified this different type of materials. And the result in slide 3 is this. This one is the marble model. You see, this is a 3D view, and here we have the views along axis. Here you see the extension of the marble. The second one is the inner dam. You see that inner dam covers here the slope. I show you the slope on the first picture, but now it's not visible. The third one is the schist model, which is practically on the backside of the quarry through the mountain. And the fourth one is the mixed zone, which is between marble and schist. And the result of processing all the information was this, which show us that in the inner dump area, it's the lowest factor of stability, 2.6. On the slopes, the factor of stability reach over 4.5, and so on. So, in order to increase the stability factor over value of 3, we made this suggestion to divide this height of the inner dam into smaller steps. This one about 20 meters, the berm of about 10 meters, and the second one another 20 meters. And in this case, the stability factor becomes 3.23. And you could see here the shape of the slope when the marble will be completely exploited. So, and the final slide for this topic. This picture was taken at the beginning of the study. It was taken from the opposite hill, which is also a marble hill. It's so-called Galloway. And You see here they started mining the marble from a marble reserve from this area. Because so here it's a commercial operation. They must gain money because no one financed them. It's a private company. The problem which encountered is that the color varies along the deposit. So in some moments, market wants white marble. In other moments, they they sell very well pink marble or white with veins. And for this reason, they started exploiting this marble reserve to satisfy the market demand, to gain money. So this was the topic about application of Surpac for slope stability analysis. In slide 3, I think that it was impossible to create a model of such a difficulty because we have had various areas with various extension and with different rock properties. So let's go ahead with the final subject of the lecture today: air quality monitoring and pollution dispersion modeling. As you notice at the beginning, here, yes. Here is a 3D model of the area. Orange Mountains. This is Petrosani. Practically, the town is surrounded by mountains. So it's like a big bucket. And we want to evaluate the air quality and how the pollutants are dispersed across the town. First of all, we identified two main pollution sources. One is common road traffic. Second one, it's not so common. It's specific to Geo Valley and to Petrosani. Geo Valley have an hard coal deposit, which was exploited for 200 years. Now, almost all mines are closed. There are 4 active mines in this moment, but they all be closed till 2030. But there are some buildings, especially in the old mining colonies, useful for heating. And the result, you could see it in the picture. Evaluating the quality of the air, we implemented 6 monitoring points along the mine roads which passes through the area. All the traffic must road, because you could see here on this Google map capture the elevation increases both on the east side and on the west side. So you could see the monitored parameters, and also in order to model, to create the model of dispersion, we need the meteorological parameters: wind, pressure, temperature, and humidity. For modeling the dispersion, we use Metelis software. Metelis software is a software funded by Ministry of Economy, Trade and Industry from Japan, and Research Center for Chemical Risk Management. We use version 2.02 of Metelis because it is translated in English and it's available on internet for downloading. Basically, the interface of the software is quite simple and allows users to enter the pollutant, the pattern of source operation, meteorology parameters, map of the area, define the coordinates of point source, or define the line source type. It could be simulate the buildings like a blocks on the map. It must be defined the receptor. Practically, receptor it's the point where the program will calculate the concentration of certain pollutant. And after all the data was entered, the calculation case allows the software to process the data and to give the result. So, for obtaining the result, we create Google Map capture with option terrain activated, and we define the dimension of the receptor grid. It's about 2.5 kilometers on 7 kilometers. You see here the dimension, and are 25 points on each row, and there are 70 rows. You see that here there is a box which allows us to introduce a terrain data file. If we don't introduce information in that box, the software made an assumption that we model a flat area. So it will not take account of the morphology of the area. So here intervened Surpac. I mentioned that the primary source of information was Google Map with option terrain activated, so we can see the elevation curves. But if we tried to take one picture, one single screen capture with all the city, the elevation curves were too small. So what was the solution? We take four screen captures, 1, 2, 3, mapping area. We establish some reference points on each picture, so that we was able to see good enough the elevation curves, which is quite accurate. So it's 100 meters between this and 20 meters between smaller ones. And we start digitizing. So it's there is a joke. It's a word for old Chinese. You must have a lot of patience to digitize all these level curves. After finishing this painstaking job, this is the result. So this is the 3D model of the Petrosani area. You could see that in the middle, it's practically the town at 600 meters elevation. And on the west, the eastern and western side, the terrain goes up. And here it's the Google map captured, overlapped on the surface model. Over this model, we drape the network of points from the receptor. In this moment, when we put the points on the surface, practically each point you will have its own elevation. Based on this information, we was able to create a file which after that was imported in Metilist, as I show you on terrain information. And we proceed to model the values of pollutants based on the data input in the model. Here is only 2 examples, but I want to show you that it is important, it's very important, the meteorological information at the moment of modeling. You will see it's a relatively calm atmosphere, not so windy. But here you see that the models shows that the pollutants are spread especially to the east. And in the east part of the road, there are practically the building apartments. So the most close building is, let's say, 20-25 meters from the road. So if the meteorological conditions are worse, they suffer first. So this was my short lecture about the subject, and now I wait your questions. Thank you.
First of all, thank you very much, for very interesting. I hope that also our students they will see the opportunity to think about this subject of applying my software in different
Different
yeah. Where I am from the technical aspect to environmental issues, or it is something that we have to take into account that an existing software is not built explicitly for specific use, it can be used for different several applications. And important because we know that mining industry is very rapidly transforming to digital one. So the use of this software is something essential for young students. I don't know what is your opinion about it. It's just, let's say,
It's like walking in the park,
Yeah.
knowing software now.
Yeah. Now, regarding the subject you have presented, I would like to ask about the second case. You mentioned that on this program also need some data regarding the buildings as blocks, as solids. I would wonder if you have taken into account this, you have model buildings with kind of software or Surpac.
No, buildings can be introduced very simple, like a rectangle with elevation.
Okay.
So it's not necessary to use another software for modeling because you don't create all the doors and the windows of the building. Practically, it's only
Still solid.
yes,
Still
yes.
solid. Yeah. Okay. Okay. Thank you very much.
Thank you. Please.
Hi, can I ask you something about the first case that you presented?
Yes.
You used the geology model from Surpac into the numerical model software, right?
Yes.
What extension you exported and imported from one to the other?
I don't remember now exactly what type of file I used because it was several years ago. But from Surpac, you could export as STR, as DTM,
Yeah.
as DXF, data exchange file, and slide 3D are able to read a lot of file formats, but it was not an issue.